Addition and subtraction of integers is best modeled with a visual, and then using the visual we can kind of come up with some rules or some cues to use when we're solving these sorts of expressions, or evaluating expressions is really what we're doing here. We have no equal sign, so it's just an expression, and we're trying to find the single value of it by using properties of operations to get one value instead of two. We have -2 minus -3. So first let's visualize where we are on the number line. Here's 0, we're starting at -2, and we're subtracting -3. So we end up moving to the right 3 units, and we end up at +1. So we know that -2 minus -3 equals +1. So what kind of cues can we use here to remember that? Well, when we're subtracting a negative, we are used to subtracting positives, and in this case we're starting at a -2, so it's not as obvious as using all positive numbers. But if we were at -2 and we subtracted 3, +3, we would go more negative. We would move to the left and end up at -5. So we can use non-examples to help us and double check our reasoning. Here we have -2 minus -3 is the same as -2 plus 3, and that equals 1. Another way we can model it is if we had red integer counters representing the -2. And then by subtracting -3, we want to take away -3. We only have -2 to take away, and then therefore we have one of the opposite of the values that we're taking away. We're taking away negatives. So if we only have 2 to take away, then there's one more, and it has to be the opposite sign. So it becomes +1. Here we have -4 plus 2. So let's model it using a visual number line. Where are we in relation to 0? We're at -4, and we're adding 2. So 2 has a lesser absolute value than -4, and it doesn't take us over 0. If we're adding 2, we're not quite making it to 0. So 2 towards 0 from -4 is -2. This is different than our first situation. We had -2 plus 3. We added a positive value to the negative, and the positive had a greater absolute value than the negative. So our sum turned out to be positive. In this case, our sum will stay negative because the +2 isn't enough to take -4 to the other side of 0. So here we have -2. It's nice to recognize that when we're adding a positive and negative, it's not always the same sign sum. So if we have -2 plus 3, we get a positive. -4 plus 2 is a negative. With addition, you keep the sign of the addend with the greater absolute value. That's very different from the rules of multiplying and dividing. So let's just remember the non-example to help us remember this set of rules. With division and multiplication, -1 times -2 is +2, right? So -1 times +2 is -2, and 1 times -2 is -2. And this is just an example, but the overall rule is that when you multiply a negative and a positive, or a positive and a negative, order doesn't matter because of commutativity. When we're multiplying the opposite signs, two numbers with different signs, then our product, or our dividend in the case of division, will always be negative. So in the case of division and multiplication, there is a permanent rule that one negative factor and one positive factor will make a negative product. And if the dividend or the divisor is negative and the other is positive, the quotient will always be negative. With addition, it depends on the addend with the greater absolute value. Let's take a look over here. We have two numbers with the same sign. So this is different than the left-hand side of the board here. In the left-hand side of the board, we were adding integers with different signs. In this case, they're the same sign. So the number line lets us visualize that if we're at 0, we're to the left of 0 at -5, and then we're going more negative, 9 more negative, we end up at -14. So when we have two addends that are both negative, here comes that awesome rule without conditions. the sum of two negative numbers is always negative. Unlike here, it depends on the add-in with the greater absolute value. Okay, and then finally, the sum of two integers that are both positive, and we're used to this one. 4 plus 5 stays positive and is 9. We're to the right of 0, we're at 4, and we're adding positive 5 more, we end up at 9. Okay, using integer counters for this one, we have -4 and +2. So I'll use green for positive. -1 plus 1 is 0. So those cancel, and we're left with -2. Up here we are left with +1. Up here we have -5, and then we add -9 more, for a total of 14 negatives. And then in that same collection of same sign, we have +4 and then 5 positive more to get +9.